AI-powered humanoid robots will make human labor obsolete in the foreseeable future. While this may sound surprising, it's the result of extensive research by a leading team of scientists and thinkers. This video will explore why this outcome is inevitable, how AI-driven humanoid robots will revolutionize the economy, society, and governance, surpassing even the impact of the Industrial Revolution. This new era will transform work from a necessity into an option, leading to great abundance but also potential challenges if we are unprepared. This disruption is not unprecedented. A similar phenomenon occurred over 100 years ago with the introduction of the automobile. Between 1907 and 1922, the reliance on horses for transportation in America plummeted from 95% to less than 20%, particularly in cities like New York, which led in automobile adoption. In St. Louis, by 1926, the number of registered automobiles surpassed that of horse-drawn wagons. The rapid shift in transportation, marked by a sharp decline in horse usage and a rise in automobiles, followed a characteristic S-shaped growth curve, known as the disruption X-curve. Historical examples of such disruptions include red fabric dyes, insulin, video rentals, cameras, and more. We are now on the brink of a new disruption: the labor provided by humanoid robots. Technological advancements in computer hardware, software, sensors, actuators, batteries, and power electronics have dramatically decreased costs and increased capabilities, setting the stage for labor disruption in the next 15 to 20 years. Humanoid robots will impact numerous industries across the global economy, marking one of the most significant changes in human history, presenting both opportunities and challenges. This overview will introduce key insights into the impending labor disruption, with future posts exploring the details of this shift, its implications, and the societal choices required. The disruption of humanoid robot labor is inevitable. Historically, every time technology has reduced costs by a factor of 10 or more, disruption followed. For example, each dollar spent on an automobile, LED light bulb, or digital camera has delivered more than 10 times the utility compared to spending on horses, incandescent bulbs, or film cameras. Similarly, humanoid robots are set to disrupt labor like never before. Consider a humanoid robot costing $200,000 over its lifetime, working 20,000 hours before retirement. This translates to a labor cost of $10 per hour. In reality, the lifetime cost of these robots will likely be much lower. Initially, humanoid robots will cost under $10 per hour, dropping below $1 per hour by 2035 and below 10 cents per hour by 2045. This drastic reduction in labor costs ensures that humanoid robots will become a viable alternative to human labor. These robots will be capable of working more hours per week than a human, without needing breaks or experiencing illness. Although initially less capable, their skills and affordability will improve rapidly over time, potentially performing nearly all tasks a human can by the 2040s. The disruption caused by humanoid robots will result in a new labor system, known as a phase change disruption. This type of disruption creates entirely new systems with distinct properties, business models, and metrics. For instance, electricity didn't merely replace whale oil. It established a new energy system. Similarly, humanoid robots won't just replace human jobs, they will create a vastly larger and more capable labor system. The key characteristic of this new system will be the rapid approach of near-zero labor costs, leading to broader changes in how we measure and manage labor. Disruptions historically involve tasks rather than jobs. Incandescent light bulbs, once rated by power consumption, shifted to being rated by lumens and color temperature with the introduction of LEDs. Similarly, humanoid robots will be evaluated based on their task performance and cost per task rather than traditional job metrics. Initially, humanoid robots will handle only a limited range of tasks and be expensive, but their capabilities and cost-effectiveness will improve quickly, making them increasingly competitive. The overall effect of humanoid robots will be a reduction in the cost of products and services. Since labor is a fundamental component of every supply chain, decreasing labor costs will reduce the cost of everything else. As humanoid robots are deployed more widely, their improving cost-effectiveness will further drive down prices across the global economy, creating deflationary pressures driven by supply rather than demand. Quality will also improve significantly. Robots are not constrained by human limits. leading to higher precision and consistency in manufacturing. The incentive to cut corners will diminish as high-quality products become more affordable, making the era of low-quality goods a thing of the past. Productivity will experience a dramatic increase. Historically, human labor has been a limiting factor in production, but humanoid robots will allow for an exponential increase in labor capacity. This will not only impact existing industries, but also enable new ones that were previously unfeasible due to high labor costs or other constraints. The availability of an expansive robot workforce will mitigate regional labor cost advantages, leveling the playing field across different regions. Investing in humanoid robots will become a national priority. Robots can be integrated into the workforce much faster and at a lower cost than training human workers. By 2035, the cost of adding 1 million humanoid robots will be comparable to raising and educating a fraction of that number of human workers. This shift will enable nations to expand their workforce and enhance economic growth in ways that were previously unattainable. Integrating humanoid robots into a nation's workforce could cost around $100 billion and take up to 20 years, while adding 1 million humanoid robots might only cost $10 billion and take 1 year. Given the rapid advancements in technology, we should anticipate that humanoid robots will soon replace human physical labor, similar to how automobiles and smartphones have evolved. The deployment of humanoid robots is comparable to investing in national infrastructure. Like roads and electricity, humanoid robots will facilitate economic productivity and improve quality of life, and nations should expect to invest significantly in this technology. This investment will create conditions for widespread use and further technological advancements. Economic self-sufficiency is another benefit. A large robotic workforce could allow smaller nations to become less dependent on foreign trade. The use of humanoid robots in national security is also significant. Nations could potentially deploy large robotic armies irrespective of their population size. Humanoid robots can be rapidly repurposed for various roles, including military applications, making their deployment a crucial aspect of future national defense. Enormous investments in humanoid robots are justified, and there's a sense of urgency to act. The scale of humanoid robot production is expected to exceed 1 billion units in the next 2 decades, with massive financial returns anticipated for investors. Public institutions, including governments and universities, should allocate substantial resources to support the development and deployment of humanoid robots as a national priority. This is similar to previous investments in basic infrastructure, which have led to increased productivity and prosperity. Experimentation and learning are essential for converting investments into real value. Testing zones resembling factories and hospitals are needed for low-risk experimentation. Various incentive programs should be explored to encourage technology adoption, while regulatory standards must be enacted cautiously to support market-driven deployment. As humanoid robots approach and eventually surpass human worker capabilities, societies that rapidly embrace this technology will have a competitive edge. The acceleration of productivity and the reduction in the cost of goods and services will also enhance the deployment of related technologies like solar power, autonomous vehicles, and advanced food production methods. This integration will create a new kind of production system focused on superabundance rather than scarcity. The impact of humanoid robots will be profound, potentially addressing major social, economic, geopolitical, and environmental challenges. As industrialized nations face demographic shifts and climate change, humanoid robots could significantly boost prosperity and problem-solving capacity. If the rate of technological advancement continues, we could enter an era of material superabundance within the next 10 to 20 years. Manufacturability will be crucial for the success of humanoid robots. The technology must be designed for mass production to reduce costs and increase volume. As humanoid robots will also operate manufacturing facilities, their design must include considerations for efficient production processes. For at least the next decade, humanoid robots will likely dominate robotics applications due to their suitability for existing infrastructure and the ease of collecting training data. Their general-purpose form will be valuable, as robots can be reskilled and redeployed quickly. While specialized robots will emerge, humanoid robots will initially be the most practical choice for various applications. Rapid deployment and investment in humanoid robots will create a self-accelerating cycle, similar to how computer hardware and software have evolved. Early deployment of humanoid robots in their own manufacturing processes will help accelerate production and development. Technological unemployment is inevitable, but there will be a transitional period where humanoid robots address unmet labor demand rather than displacing existing workers. During this time, humanoid robots will serve as a force multiplier for existing jobs. However, as robots become more capable, they will directly replace human workers, necessitating a reevaluation of economic structures and social contracts. It is crucial to use the current period to plan for the eventual technological unemployment. This involves avoiding complacency and preparing for a stable transition to a future where human labor markets may collapse. Protectionist measures to preserve existing jobs will likely be counterproductive, leading to economic stagnation. Instead, society should focus on adapting to and embracing the changes brought by humanoid robots. The initial demand for humanoid robots will be high, leading to competition among various firms to meet different market needs. Companies will develop a range of robot offerings for diverse applications. As demand exceeds supply, multiple firms will have opportunities to target different niches, regardless of their market position. The primary goal should be to protect people and not just industries or firms. Historical examples show that protections for incumbent industries often benefit only a few, while a broad societal focus on adaptation and transformation is essential for managing the disruption caused by humanoid robots. In summary, the rise of humanoid robots presents both challenges and opportunities. Embracing this technology rapidly and planning thoughtfully for its impact will be crucial for achieving a prosperous and stable future.